In Module 2, Lesson 1, we're going to interpret the division of a whole number by a fraction by using visual models to show. In the class, we would receive a card with a common fraction on it that you would then need to draw a model of. So if you're doing this outside of class, please choose a common fraction like 1/2, 3/4, 4/5, 5/6, 5/8, 7/8, any of those common fractions, and draw a model of that fraction. Then follow by describing what the fraction means. Describe what the numerator means, what the denominator means, and each part that you drew in the model. In example 1, we're going to see how we might solve this problem using some models. Maria has 3/4 pounds of trail mix. She needs to share it equally among 6 friends. How much will each friend be given? And what is this question asking us to do? First of all, we know that Maria has 3/4 of a pound, and she's going to share it equally. Sharing equally, as we have talked about in elementary school, means to divide whatever you have by that number. So the question is asking us to share 3/4 pound equally among 6 friends, which is division. We're going to model the question both with a number line and also with a fraction bar so we can see several different ways. So you can see that our number line and our fraction bar match each other. They're each divided into 4 equal parts. Please note your denominator is 4, so we took the whole piece and we divided it into 4 parts. Then we are talking about 3 of those parts, so our numerator 3/4 recognizes the 3 parts that we're talking about, and the whole is cut into 4 pieces. From the problem, we know we're going to give equal amounts of trail mix to each person. So to show that in the model, we will need to divide the 3 parts that we have into so that it becomes 6 parts altogether. And in order to get 6 parts from the 3 that we already have, we'll need to divide each piece in half. One, two, three, four, 5, 6. We have 6 equal pieces to share among the friends. On the number line, we can do the same thing. To make equal divisions, I'll also divide the piece that was not used in the problem because we only had 3/4. But dividing that last part will allow us to see how many equal pieces we have in one whole. So when we look on the number line, we can see we have 1, 2, 3, 4, 5, 6 pieces. And there are 8 pieces altogether on the number line. Same way with our fraction bar. So what we're actually showing then is that each person would get 1/8. Therefore, 3/4 divided by 6 equals 1/8. The visual model is actually showing that 1/6 of 3/4 is 1/8. This is an example of partitive division. You can tell because we were given the original amount of trail mix and how many parts of trail mix to make. We have this amount and we needed 6 parts. We needed to determine the size of each part, where the size of each part is less than the original amount. Let's look at a slightly different example. Imagine that you have 2/5 of a cup of frosting that you need to share equally between 3 desserts. How would we write this as a division question? 2/5 divided by 3. We can start by drawing a model of 2/5. So we'll shade in 2 pieces of the 5 pieces in our model. Then we need to divide these 2/5 by 3. So we need to make 3 pieces out of these in the 2/5. We could do this vertically, but let's try doing it horizontally because sometimes it's kind of confusing to do it up and down. So if we take our whole model and divide it all by 3, because although we're not using these other 3 pieces, it will allow us to find out what size each of the pieces are in the sample that we're looking at. And so when we look at how we accomplish that, we're still talking about 2 pieces, but the pieces now are 15ths because we have our model divided into 5 pieces across and 3 pieces up and down. 5 times 3 is 15. That means that each piece is 1/15, and we were talking about 2 of them. Again, showing mathematically, we can show that 2/5 times 1/3, because we divided into thirds, equals 2/15. We're going to continue on in the exercises, not only representing with models, but also showing how we use multiplication to solve these problems. The first question, 1/2 divided by 6, can be rewritten as a multiplication question by taking the 6 and turning it into its reciprocal. If we divide a whole into 6 pieces, we're actually creating 1/6. Each piece in that division would be 1/6. So dividing by 6 would be the same as multiplying by 1/6. And 1/2 times 1/6 equals 1/12. Showing the problem visually helps to verify the math. We started off with 1/2 of our fraction model, as you can see in the yellow shade, and then divided that half into 6 pieces. 1, 2, 3, 4, 5, 6. We continued by dividing the other half of the fraction model into 6 pieces as well. Once we do that, we see that we have 12 equal pieces on the fraction bar. So our denominator would be 12. And we were only talking about one of them. So 1/2 divided by 6 is 1/12. In the same way, if we take 1/3 and divide it by 3, let's draw the model first and then we'll show the math. So I've drawn the fraction bar and I've made it into thirds. That's how we can represent 1/3, shaded 1/3 of that fraction bar. And now we are going to divide each piece by 3. We can then see that we have 9 pieces altogether, and the parts that are shaded are 3 of them. But we only want to talk about one piece because that's our numerator. So 1/3 divided by 3 would be 1/9. And if we do it mathematically, we would multiply 1/3 times 1/3. Since dividing by 3 is the same as multiplying by the reciprocal of 3, which is 1/3. And 1/3 times 1/3 is 1/9. I'll let you do number 3 on your own, and we'll skip to number 4. Because in number 4 we are not working with a numerator of 1. So we're going to model 3/5 divided by 4. And I have our fraction bar representing 3/5. And we're then going to take each piece and divide it into 4 pieces. But before we do that, let's show it mathematically and see if we're correct once we divide our fraction bar. So mathematically, we would have 3/5 times 1/4. And when we multiply fractions, we multiply straight across. Numerator times numerator, and denominator times denominator. So 3 times 1 would be 3, that's our numerator. And 5 times 4, which are our two denominators, would be 20. So we should predict then that our model will show 3/20 when we're done. Let's represent this one by dividing horizontally, since our original divisions are vertical. So we'll divide it across into 4 pieces. My line's not perfectly straight there, but we'll be okay. 1, 2, 3, and there's a little piece there, 4. Each of the pieces in this new model would be a 20th, because we have 5 across and 4 up and down. 5 times 4 would be 20. There are 20 pieces here, and the part that we wanted to talk about were 3 at a time. We know that from our original numerator. 3 pieces, and each of those pieces is a 20th. So our model shows that our math was correct. Let's do that again with 2/3 divided by 4. We'll start by creating a model of 2/3. And we'll shade 2 of them. And next we need to divide that again by 4. So we will do that horizontally as well. And the number of pieces that we now have in our model, we have 3 across and 4 up and down. So 3 times 4 would be 12 in our denominator. And our numerator should end up being 2 as well. The numerator would be how many across we are. So 2. And we said our denominator should be 12. So now let's check it mathematically. If we did 2/3 times 1/4, multiplying the numerators, 2 times 1 equals 2, and denominators 3 times 4 equals 12. So we see mathematically that we're showing the same amount. And we've done both ways. We have done the math first and then checked with the model, and we've drawn the model and then checked with the math. Finally, when you get an answer, you may notice sometimes that that fraction could be simplified, as is in the case in number 5. 2/12, each of those numbers is divisible by 2. So we can simplify that fraction into 1/6. Continue on completing the rest of the examples that we did not do together, and also the problem set for class.